Hello everybody, my name is Celso. In this video I will be explaining the two types of collisions, and I will explain to you how to use kinetic energy along with momentum to analyze a collision. Okay, so there are two types of collision, elastic and inelastic. Elastic collision is when the two objects hit each other and bounce off each other. Inelastic collision is when the two objects hit each other and keep moving in the same direction stuck together. So in both collisions, you want to remember that linear momentum is always conserved. However, the total kinetic energy is going to change. I made this simple flowchart which asks two questions, and if you answer yes, if you answer yes to both of these questions, it will determine that the collision is inelastic, and if you answer no, it will determine that the collision is elastic. These are a set of rules and formulas and equations that we'll be using. In the first formula that you see, you read that it says potential initial equals potential final, and the one under it reads kinetic initial equals kinetic final. These two formulas will be used to solve most type of collision problems. Okay, so in this illustration I will be showing you 5 different examples of elastic collisions, and in all 5 examples it is very easy to determine that it is an elastic collisions, as you can assume and infer that in every example there are two objects colliding with different masses, and both objects go their separate directions and and they have different velocities. Okay, in this illustration I am showing 3 examples of inelastic collisions, and as you can tell, there are two objects going in the precise opposite direction at different velocities with different masses, and when both objects collide, the mass is combined for a total mass value, and it continues in one specific direction. Here's an example of elastic collision of a young soccer player who is playing the game of giant soccer pool game. He initially kicks a 4-kilogram ball east at a speed of 5 miles per second and strikes a 2-kilogram ball that was initially at rest. He missed the intended hole. However, what is the final velocities of the two balls, assuming it was a perfect elastic collision? So you can tell that we use the momentum equation and the kinetic energy equation, because we are solving for two variables, the two missing variables which is the two final velocities. Here's an example of inelastic collision of a 13-kilogram car moving at 20 miles per second and a 900-kilogram car moving at 15 miles per second going in precisely opposite directions. Both cars perform a head-on collision. If we consider this event to be a perfectly inelastic collision, what is the speed and direction of the cars after the impact? Okay, for this problem we will be using the conservation of momentum formulas and the conservation of kinetic energy laws to determine the strategy we will use to solve the solution. I ended up using the conservation of momentum energy equation and ended up solving for a final velocity in the right direction. And this concludes my video. I hope you guys have a better understanding and gain a couple insights on how to identify these two types of collisions. I hope my flowchart was able to help you determine how to identify the two types of collisions, and I hope my real life example illustrations help you get a clear image and clear path of how to identify these two types of collisions, because it could get very confusing.